Hello everybody, my name is Tim O'Brien. I'm the proposer for a project in Catalyst called AI AppBuilder for Cardano. So about me, I'm an ex-Googler and CEO and founder of QModeler, which is a no-code application platform for developing blockchain applications. So how did the idea come about? On the left you see our product, and it works by users dragging and dropping icons onto an artboard, connecting them in ways to produce the logic of their application, and then we synthesize this into smart contracts. So we want to actually pull this out of our product, and rather than users assembling them, we want to have some AI be able to take in a specification and do the assembly that you see on the left side, instead of having a user drag and drop to produce their logic. So components, we see here 3 components, and there could be many different applications built even from 3 components. And our components are not just like data flow from left to right. Our components excuse me, have many ports, so there are many ways that even 2 components can interact. So 3 components could even have hundreds of different applications be built from them, and then we will eventually have hundreds of different components. So I'm going to show here an example of how this is done in our product, and pay particular attention to what goes on in the upper right hand side here. This is our guiding system, and it's brute force and genetic algorithm driven. So what we see here is that what we're going to observe here is the user really isn't making any decisions. The guide is going to provide the user with all the instructions to build the application based on certain DNA that he's entered, the description of the project that he's entered. So everything from connecting, which elements need to be connected, which elements need to be on the artboard, and then we're going to see here connecting and selecting the different ports. And in this case we see the user demoing how you can connect a port, but the port has already been connected on the right hand side. So so let's do this with AI. It should not be if we can do that with AI, then we have the first application that assembles full applications using AI. So one of the approaches that we explored is using deep generative models of graphs. And the reason we explored this is because this is precisely what has been used to build applications from Legos very successfully. So we can see here, we'll put some links into the video here, so you can go to the white papers and the examples. But it's really easy to configure for new kinds of problems, so we can reuse a lot of the code. And we see here it's got nice peaks, which is what we're really looking for, because as we saw that even 3 components, if you give an incomplete specification, may return many different results. And this is useful because the user can actually select which one of the 7 or 8 results that are returned. The other option here is deep learning. So our product here actually doesn't depend on a language. It depends on a game called Pebbling, which actually happens to be Turing complete, so it can be reused to replace algorithms. So I'm sorry, can be used to replace programming languages. So what we see here is we have a Pebbling game. The Pebbling game works like this. You have excuse me, input places. You have operations, and when enough pebbles are on the input places, you transition to an output place, and we do so again. So using deep Q learning, a solution that would actually have a winning strategy for this game, it's a 2-person game, can actually then be the solution that would assemble a project for us. So what we have here is just some heuristic. Go, everybody knows that that Q-learning has defeated Go, Lee et al. And Go has about 10 to the 36 possible moves in a game, which is quite a bit more than the number of atoms in the universe. For pebbling, we probably have far less. In the examples we show, we probably have 2 to the 2 to the 5. So deep Q learning has demonstrated its ability to solve many board games. You can go to OpenGym and see how, and follow instructions and see how you can train your own deep learning algorithm to defeat board games and games like Pac-Man. So it's also quite democratized and quite easy to use. So to sum up, I think we have a big proposition for you. Thus that we can actually build software based on specifications without any coders or any developers. We think this is obviously will be a giant leap forward in software development process, and we're quite confident based on our experimentation that this can be accomplished. This is still, caution you, this is a research project, but one that I think we have high confidence will produce the results that we expect. So we think this is an excellent use for ADA and for your vote. So we would like to invite you to come in and vote for this very exciting project. Thank you.